Today is a really exciting day. I've been waiting for this moment for about 6 months now. I ordered a new piece of equipment for the shop, and last week I finally got notification that it shipped. I've been tracking this thing every day for a week now, and today is the day. It finally came in, so let's open it up, see what it is, and I can't wait to learn how to use this new technology and start integrating this into all of our projects. Don't forget to give this video a thumbs up, hit that bell for notifications, and subscribe. So what we have inside this box is a state-of-the-art new invention by a company called ArcDroid Plasma. You can find them on Instagram under the name ArcDroid Plasma, no spaces or periods or anything. This thing is sweet. It is a benchtop, portable, robotic CNC plasma machine that utilizes your standard handheld plasma cutter. This thing is awesome. It comes with its own control. It comes with software that does all of its own design and trace function based off of simple patterns that you can make just with paper or cardboard. This thing looks awesome. I had to have one. I jumped in on the super early bird special when this thing was still in development and it was still being funded. I jumped in, helped fund the project, and got one of the first units. I can't wait to get this thing opened up. Let's check it out. Okay, so it looks like here, I'm not sure what this is exactly. This might be the calibration tool. We'll figure out what that is soon. Check that out. So far the packaging I'm pretty impressed with. This is developed and engineered by an inventor in Canada, and real nice guy. I've been following him for a long time. The machines are manufactured in China, but all the R&D, everything, the company ArcDroid is all Canadian based. It seemed like he really took his time and really nitpicked every last detail of this machine, was giving us updates the whole time. I was real impressed with his business and I jumped right on board. So let's see what we have here. Okay, so this is the tracer pen. This is the part that allows you to do on-the-fly CAD design. This is the feature that really sold me on this unit and got me interested in the first place. So this one's probably the one for attaching your torch head. Yep, okay. So this is how you clamp your handheld torch to the machine. The best way to get the whole unit out of here is, okay, what's this over here? I think we'll take that out after the unit. Let's get underneath it here. Let's get this foam off of here. Let's get the box out of the way. Yeah, this is packaged very well. I'm impressed. And you can see how small this machine is. It's awesome. I mean, when you're not using it, you can just set this on the shelf, out of the way. You don't always have some gigantic plasma table taking up shop space just for doing one-off R&D work. And there's one more thing here. This is the controller. Oh, that's in there tight. Again, this packaging is very well thought out. Control head. From what I understand, this is all touchscreen, and hopefully it's as easy to use as they say, because I have no CNC CAD experience. So this is another reason I bought this machine, because this seemed So easy to use, which really got me excited to getting into this new technology. Get the rest of this foam off of here. So this has height control. It's all cable operated. So the instructions are basically one single sheet of paper. The front is a whole bunch of disclaimers, basically telling you how not to hurt yourself. And on the back, there's two steps. The first one says that you have to run the calibration before using the machine. And the second step is basically telling you you need to hook up your plasma cutter to activate the plasma on-off switch. And some basic user interface functions. But on their website, we can find more information, more instructions, and they have a great YouTube channel with some tutorials as well. So let's check out how this torch mount hooks on here. It's got these quick release arms, which is pretty sweet. And it looks like it just hooks on here like this. And you latch that down like that. I like it. That's really secured. It's tight. That's nice. My initial assessment of the construction overall is I'm pretty impressed. It seems really sturdy. It's on this 1/4 inch thick steel plate. This is a nice cabinet hiding all the electronics and the motor. This upper arm, this is all aluminum. It's got bronze bushings on everything where the height control and the cable is. The powder coating on it is very, very nice. It looks like a nice piece. It has two contactor switches exposed on the top with some what appears to be exposed like circuit board with some solder joints on it. It looks like there might even be some LEDs on there possibly, if I'm looking at that right. It looks like when this thing is homed, you can hear those switches compress. That might have something to do with the calibration or the homing of the arm. A little concerned in a shop setting with lots of grinding dust and dirt, having some exposed solder joints and things like that. So time will tell how these live up to an industrial environment. Definitely a machine I'm going to keep covered when I'm not using it. We've got some connections in the back, your main power switch, a place for the cord. This all looks very nice. On the side of the unit, we have some computer hookups, probably where we plug in the control module. This top slot kind of looks like it's for a micro memory card. We'll see if I'm right about that soon. Let's start opening up some of these packages and see if we can get this thing turned on. This is the control panel. This is all touchscreen. If you push this in, it's kind of like the enter button. Let's go ahead and get the screen protector off of there. Got the main power cord. I believe this is part of the calibration tool. So we're going to play with this here in a few minutes. I'd like to set this all up and run an initial calibration, and then we'll talk some more about all the features of this machine, some of the awesome things that it can do. Have a cat cable. I'm just going to assume that this is to hook the control head to the actual robot itself. And then these little brass screws with points on top of them, these are part of the calibration tool. And this should be the entire calibration tool. Get this opened up. That one is labeled 2. This is all like saran wrapped. Careful not to bend these. So this is the calibration tool that you have to do every once in a while. You definitely have to do it when you first set it up. There is a YouTube video on ArcDroid's website on how to do this calibration. I viewed it ahead of time. I'm going to check it one more time before I actually try to do this calibration, but it seems super easy. He does the whole thing in less than 3 minutes. This calibration tool requires some assembly. It's just 3 screws, and basically you're building a triangle that has all these holes in it. It uses this to run on this track, and it locates the position of all these holes. And basically they say that you might have to run it every once in a while just to keep everything up to par, make sure everything's staying super accurate and precise. So depending on how much I use this machine, if I use it a bunch and then I set it aside for like a month and don't use it and I drag it out, I'd probably want to recalculate it when I drag it out after it's been sitting for a little while. Let's get this thing assembled and try to run our first calibration. So this one has magnets on it, which is cool. It also has a number 1 on it. This one has a number 2. It's also got arrows. Okay. See if we can figure this out here. Fortunately, they don't give you a picture. But I believe it goes like this, based off of their YouTube video. Now these little pointed screws, screw it all together, and they are 8mm hex. Let's just snug that up. Okay. It's nice that they have magnets on the bottom side so you know which side goes down. And they say you should clamp this to the bench just so you know that this doesn't move during the calibration process. Okay, let's get this sucker clamped down. Okay. Number 1, arrow this way. Number 2, arrow that way. Number 3, arrow that way. It's very important that you have to use these pointed screws because you are going to center on top of those at one point to confirm your calibration. You'll notice that the feet of it have these little half moons. And on the base of the unit, there's half moons on the base plate. We're going to key those together, get it snugged up, and we're going to clamp the machine to the table as well. All right. Keyed in, keyed in. They say to calibrate it accurately, and even when you're operating a machine, you should have it level. So we're going to take this little bullet level. They want you to put it right here on top. Let's level this up in both directions. Let's get the electrical connections hooked up. We're going to put the power cord on it, hook up the pencil stylus for the trace feature, as well as the control module. Let's hit that power button and turn it on for the first time. Cat cable. Let's turn it on. That was a really fast boot up. Now we need to hook up the trace pen in order to start the first step of this calibration. But when I go to put the trace pen on, the robot arm is too low close to the table for the trace pen to fit. So I'll show you how you raise that up with the control panel so you can get it to fit. When you're in your home screen, if you turn this knob, you can raise. You can see that arm's going up, or I can lower that down. So I'm going to raise it up. Now we should be able to fit this on here. Lock that in. And it looks like it even needs to go a little higher, so let's go up a little more. Pretty much all the way up. Now we need to take this little runner that runs on this track. We need to put it on rail number 1, the arrow on the pointer pointing in the direction of travel, the arrow on the rail. And we're going to plug this in to the port right here. Now we need to get into calibration mode. So let's go down to settings. I noticed on the camera it looks like this is flickering. It's not flickering in real life. That's just the frame rate on this LCD screen. But go to calibrate. Now there's specific instructions on here on how to start your calibrate. Starting, plug in USB drive to save your results. Stay clear of machine homing motion and press next when ready. So they want you to put a USB drive in the side of this to save your settings to. USB drive. Now it's guaranteed that the first time you try to plug in a USB, you try to plug it in the wrong direction. Alright, so that's plugged in. So it says, starting, plug in USB to save results, stay clear of machine from the homing motion, and hit next when ready. So I'm going to just assume that this is going to home itself, so don't have your fingers anywhere in any of the moving parts. Let's hit next. Okay, so it appears that both axes, this one and that one, came in, touched the homing switch, saw some lights flash. It must be homed now. Now it's telling us to install the stylus to the arm and press next. We already have the stylus on there. Let's hit next. They want you to place the shuttle on the rail. So I guess we shouldn't have actually put that on yet. We're going to place it on the rail. At position 1, which they're showing you on the tool here, see how they show it keyed into the machine with these little feet? Position 1, get that set up. Lower the tool onto the cone aligning hole. So they want us to bring this over with our hand, place it over top of the pointer on the sled, and then lower this down until the tip of the pen is right on top of that cone. And we should be able to lower this. Okay, so I brought it down and the tip of the pen is hollow, and even though I didn't have it perfectly centered, as I brought this down slowly, it centered itself on the top of that cone. So place shuttle on rail at position 1, lower the tool onto the cone, and align the hole at the tip. Hit next. Move the shuttle and the tool slowly from one end to the other. Press next when done. So it wants just to slide this down to the other end. And every time the contact switch in this sled passes one of these holes, it's going to receive that information and plug it into the machine. I'm going to put a little downward pressure on the pen while I hold the sled down against the rail. We're going to slide it from one end to the other. They say to go nice and slow. Don't just zoom it across the other side. Okay, so I got to the other point where the sled stopped. The machine picked up every one of those points and it relayed all that information, that's every one of those points, back. So we completed that step. Now it says hit next. Now they say place it on rail number 2 and do the same thing again. Move this out of the way. Let's take the sled, put it on rail number 2. Bring the stylus over. Let's control this down. I keep wanting to say Control Z because thinking of a CNC milling machine. That would be kind of the Z function. So we have it aligned on rail 2, holding the sled down, hit next, move the sled and the stylus down the rail. We made it to the other end. It picked up all those points. We're going to hit next. Now they want you to put it on hole 3. Same thing, slide it down the rail. I'm putting downward pressure on the pen tip to make sure it stays in the cone. And I'm sliding the pen down the rail as well as the sled down the rail. So we made it to the other end. When done, hit next. Now they want you to switch to the torch head. So here's the torch head here. I don't have my torch installed yet. So let's get the torch head installed in this clamp. We need to switch this out with the stylus. And basically we're going to repeat that exact same process on 1, 2, and 3 with the torch installed. Alright, this is my hypertherm. In order to be able to officially use this, I need to wire in a 2-wire connection into my torch handle, which I have to look into how to do that. It seems pretty straightforward. Anyone smart enough to use a machine like this should easily be able to take this apart, find the 2 wires for the contactor for the switch, and run either a weather pack connector or some sort of 2-pin connector out of the back of your handle. Snug these up, they're just 10 mils. Alright, hypertherm head is mounted in. Quick and easy. So we're going to hit next. So now it wants us to go back to step 1 with the sled. We're going to hit next and it's going to tell us to slide it to the end. Then we're going to do 2 and 3. Okay, so that is centered real well. Next, they want you to slide it. Okay, we made it to the other end. Next, do 2. Okay, that is over the tip. Hit next, slide it down the rail. Got to the end. Next, Z up and to 3. Slide it down the rail. You can hear that contactor hitting every one of those holes. Alright, that's the end. So I don't know if that's the last step or not. Let's see what this says. We completed that. Let's hit next. solving parameters. Something good, blah, 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 blah. Press next to apply settings or exit to abort. Next to apply settings. Settings saved to machine. Stay clear of machine and press next to rehome. So I am going to move this up and get this out of there. Hit next to rehome. Okay, and it's back to this screen. We can go exit, and we're back to the home screen. Now let me show you why this machine stands alone with some of its technology and why I was so excited to get it into my shop, because some of these features are just amazing. Now the awesome thing about this is this trace feature. You put this trace pen on your arm. The trace pen has its own button right there. You can also use this push button, which is also the control knob, but you push that in, same as pushing the button on the pen. Now, if you're a fabricator and you need to make any brackets, tabs, any plate work, anything like that, that you might use a plasma cutter for, you always start with CAD. No, I'm not talking about that fancy computer-aided design stuff. I'm talking about cardboard-aided design. You always start by making a cardboard paper template of the plate, bracket, tab that you want to design. So let's make a quick generic template and I'll show you what the next step is. So let's say we needed a bracket or some sort of plate tab or something for an engine mount, or who knows. Let's say we needed something like that. Could even have like some bolt holes in the middle of it. Could have some rounded corners. In fact, let's make a rounded corner. Let's make this one here. Let's make this a radius corner there. Okay, so let's say that this is the template we made with our cardboard aided design. We need this out of plate steel. Now, if you're like me and you don't know any of that fancy computer aided design, you don't need to know how to use any of that stuff to be able to utilize this CNC controlled plasma cutter. All you need to be able to do is what you've been doing all your life, cutting out paper templates. I'm going to put a magnet on here just to hold it still. Now here's the beautiful part. Go to your control panel and hit the function that says trace. Takes you to this screen here. Now we can manually take the arm out, and if you look on the screen, everywhere I move this arm, it moves the pointer on the drawing screen. We can bring this over to any point on our template. We can use the control knob to bring the stylus down to the table and go right onto the edge of the template. That shows our location on the main screen. Okay, now I'm going to hold the button on the pen and I'm going to trace the outside edge, and it's going to draw it onto the screen. All right, now I wasn't being very steady, but for my first attempt at ever doing this, it came out pretty decent. So here's our pattern, and here it is drawn on the screen. Now I need to figure this all out, but basically we can convert this to a cut pattern, and then we're going to home this on our piece of metal and hit cut, and we can blast that out in one shot. Let's say we were trying to pick up a bolt hole. We wanted to put a bolt hole right there. You're going to put your stylus right dead center of the bolt hole. On your screen, you're going to select circle, And since the stylus is in the right spot, we can either hit the button on the stylus, or you can hit the enter button on here, and we can pick up that point. What that does is it places a circle around the center of that stylus. Now right here, we can change the diameter of that hole. It's telling us the X and Y coordinate of where that hole is on the entire sweep of the machine. So you're not really going to change that because we physically picked it with the stylus. We put it right where we wanted the middle of the hole. So what we could tell it is the diameter of the hole, and then we can actually change the lead-in dimensions. I can hit check mark. Let's just leave all this stuff. Diameter 60. Let's just check mark. Okay, so we just put a bolt hole right there. Let's move the stylus over here. Let's move it right there. Let's say I want to put another bolt hole right there. We're on the circle feature. I'm going to hit the enter button or the button on the stylus. Okay, now we're picking up a circle there. Let's change this one to 50. Okay, so I typed in 50. Now I'm going to hit the check mark. Okay, so now we have a bolt hole there as well. Okay, now let's do some point-to-point. So in the freehand drawing, it also has a point-to-point in the same picture, because tracing a perfectly straight line without like an edge to follow, just drawing it on top of a piece of paper, is hard to do. We could lay like a piece of steel here and then have it up against it and use it like a fence, but there's a feature that's really nice that makes this super easy. So you can see where our stylus is pointing. Let's just bring this over to the corner. So there's our stylus. Just tap the button, don't hold it, just tap it. Okay, so it picked up that point. Let's bring this to the other end of that straight line. Now you see there's no line drawn, but there's the first point, and here's where the stylus is currently at. If we hit the button, the line appears. Let's go to the next straight line point. Hit the button. Next straight line point. Hit the button. So you can see this entire pattern is being drawn on there. So you don't have to try to squeeze this and draw a straight line because you're all over the place. Look at how squiggly that line is. But you can pick a point and pick a point and draw nice straight lines. So just a few of the reasons that I jumped right on purchasing one of these ArcDroid CNC plasma robots is, number one, its size. This thing is super small. It's a benchtop unit, fairly lightweight. I can pick this thing up and put it right on the shelf, cover it up, keep it clean, and out of the way when I'm not using it. I am not a cut shop, and I don't ever plan on being a cut shop. I have no intention on producing plasma cut products to sell. This is for prototyping and for making onesies and twosies, or maybe 10 of one part for the jobs that we do in-house, and I'll probably never make that individual part ever again. So when I need it, I can set it up on any table, do a quick calibration, and make the parts I need real fast, real easy. When I'm done, up on the shelf, out of the way. I'm not walking around some 4 foot by 4 foot or 4 foot by 8 foot table all year round for the couple of times a month that I'm actually going to need it. The other main reason is its simplicity of use. I don't have to take the time to learn all the computer design, all that software, just to have a CNC plasma machine in my shop. I can save all that learning curve for later. With its built-in interface right here, I can easily use the trace feature or draw right on this screen with basic geometry and math skills, and I can produce real parts real fast. When I do get to the point when I'm designing sophisticated things with some sort of computer software, this machine is still 100% functional. I can put that stuff on a flash drive, plug it right into the interface here, pull that file up, and run the cuts. So it's not limited to only what you can draw on this integrated interface. You can still use the complicated computer programs like AutoCAD or Fusion 360, all that fancy stuff. If you know how to use that stuff, draw it on there, put it on a flash drive, put it right into the user interface for the ArcDroid, and hit cut. So that's what really attracted me to the ArcDroid, was its size and its ease of use. I really look forward to making some awesome parts with this machine. It's going to be a huge asset to the company, and it's going to save a lot of time when we're making prototype parts or just onesies and twosies of brackets and tabs, where normally I would use the iron worker or the bandsaw, and then I would drill the holes in the drill press or use the punch to punch the holes, and use like 5 or 6 different machines and a bunch of time just to make 1 or 2 brackets. And they already started with the paper pattern. I can take that paper pattern, just lay it on the table, trace it out with the ArcDroid pen, get a piece of metal out, and hit cut. In our next ArcDroid video, I'm going to show you how I hook up my Hypertherm plasma cutter to the ArcDroid and get all the control features working. Then we're going to make the first ever cut. I really hope you enjoyed the unveiling of this machine. We got it unboxed, we got it calibrated, we even played with some of the basic features and the controls, and this looks like it's going to be a little bit of a learning curve, but it seems really, really easy to figure out. I look forward to making lots of videos of us using this machine, learning how to use the machine, and some of the cool things that we're going to be able to do with it. So stay tuned on more videos of us using the ArcDroid CNC plasma robot. Make sure to give it a thumbs up, subscribe, and turn on that bell for notifications. I'll see you on the next one.